Hello students, let's continue our discussion in computer graphics. So earlier in the previous video we have discussed about the reflection, right? A kind of transformation, even though it is not a major kind, but obviously it is considered as one of the type of the transformation. So the another type of another type, not a major but a general form, or you can say it's a minor form of transformation is shear. Okay, let us see what it is. The exact meaning of shear is nothing but a kind of the same object which slightly appears to be a composite one. In the sense, take an example of the chalk box. Okay, better I'll show the picture. Assume it is a chalk box. Okay, this is the front view of the chalk box. So what I am doing is I am just slightly pulling one of the portion of the top end of the chalk box towards right. How does it appears? See here how it appears. It appears like this, something like this, isn't it? The base remains same, only the top portion slightly I used to pull on one particular direction. So what will happen, right? Slightly this portion is moved towards right because I hold it somewhere over here and pulled the top portion of the empty chalk box, getting no, since it is an empty chalk box, so I can slightly change its what you can say shape, so without moving the object. The main thing or important thing is you are not supposed to move the object. Moving stands for always translation. We are not doing that. We are keeping the object at same location, but what I did, I slightly pull one of the portion of the same chalk box, empty chalk box, without changing its original base position. So this type of transformation is called as shear. Let us see how the shear matrix. Earlier we have considered, we have seen how reflection matrix to be written, right? In the same way. So see shear once again can observed in the along with x-axis, or even it can be observed along with y-axis. Okay, let us see how to write the matrix content for it. X direction shear is can be written by using the formula. This is what the standard formula you're supposed to remember. You're supposed to remember, see, x direction shear. What we are doing, slightly we are updating the value of x, since observe the diagram once again, the diagram what I said. So slightly the direction, x direction, slightly it is pulled towards right. So original position, the x parameters gets changed. So initial values of x on top, just observe these 2 points, okay, 0 1 as well as 1 1, where x refers to 0 leftmost point, top left, and the top right, x refers to 1, but which is slightly changed now, right? Sorry, observe here, which is slightly changed. The x parameter is changed of top point, say 2 1, it become 2 1 and 3 1, isn't it? So x coordinate shear, x coordinate shear is written as x in addition with, that is x dash with, which is equal to x in addition with shear factor sh of x in multiplication with y. Okay, y is the relative position, then y dash equal to y. We are not going to any update any value with respect to y, so y dash remains y, where x dash equal to x in addition with shear factor for x in multiplication with y. So while writing the matrix content, just observe, it is easy to write the matrix content. This is what equation number 1, okay, call it as equation number 1, and this will be equation number 2, isn't it? So equation number 1, first row, equation number 2 will be written in second row. What is the coefficient of x? Coefficient of x is 1, coefficient of y is what? sh of x, that's what you have to write. Okay, third parameter remains 0, and equation number 2 you observe, here coefficient of x, there is no x factor, so nothing, just go to 0. What is the coefficient of y? 1 into y it is, so coefficient of y is 1, which is written, and then 0, right? Third parameter 0 0 and 1. This is how we write the shear matrix. And one more thing, we can generate the x direction shears relative to the other reference lines. Okay, relative to other reference line, maybe y or any other reference line. So generalized shear matrix along with x direction, okay, relative to any other plane. This is what the generalized matrix content. So we are considering the third factor, that is sh minus sh into y reference. Okay, derivation part is not there for your syllabus, just remember the formula. Okay, it uses some trigonometric properties let it be. Just try to remember the matrix content, either matrix content you remember or formula. So earlier what we did, x plus sh into y we have considered. Now this time you have to consider, see, y minus y reference. After simplification you are going to get these things. Okay, so sh of earlier sh of x in multiplication with y we have considered, isn't it? Observe the previous formula, you will come to know. Okay, see here, x dash which is equal to x plus sh into y we have considered. So what we are doing, we are rewriting the formula, generalized formula as x plus sh of x into y reference minus y, right? Y reference minus, sorry, y minus y reference. Okay, y minus y reference, this thing you have to remember. After simplification you are going to get this particular matrix content. Okay, that is along with x direction. So this is called as x direction shear in generalized case. So y minus y reference, please remember, sh of x in multiplication with y minus y reference you have to consider in generalized case, that is for shear of x direction. Now shear on y direction we can write in similar way, sorry, shear on y direction, as you can see here, what we did, we just considered, say, x dash earlier, shear on x axis, y dash remains y. Now shear on y axis you have to take vice versa, that is x dash which remains equal to x only, but here you update the things, y dash equal to, earlier how you written x dash equal to x plus sh of x you have considered. Now you have to consider sh of y. See, y plus sh of y in multiplication with, earlier it was y minus y reference, this time it should be x minus x reference. Check, that's it, very simple, just analyze, you will come to know. So it is exactly vice versa thing, replace the x by y, y by x, that's it. This refers to y direction shear. Okay, y direction shear generalized formula. Okay, generalized formula by y direction shear with, by keeping any of the plane as the reference plane. uh, what will happen for y direction shear, x dash will remain equal to x. You have to take vice versa for x direction shear, y dash equal to, which remains equal to y, as you can see. Sorry, see, for x direction shear what happened, y dash which is equal to y we have taken already, isn't it? So this is for y reference shear. uh, so y axis shear, so x dash equal to x and y dash equal to y in addition with, so replace x by y in the previous formula, you will be getting the answer. If you know this, then easily you can write the matrix content. Okay, uh, hope you are all understood how to write the matrix content. See, x dash equal to x, first row refers to x, isn't it? So coefficient of x which is equal to 1 and the remaining factor will be 0 only, and later coefficient of x first term itself is y, so sh of you have to simplify that, sh of y into x you will be getting, that sh of y should be taken over here as the first term coefficient of x. Okay, after simplification you will get, you open that bracket and simplify, you will come to sh of y into x, it will be minus x reference into sh of y, isn't it? sh of y into x reference minus of, that is the third factor, second factor will be y only, that is coefficient will 1, right? That's all about the shear. Let's continue our discussion in the next session. If you have any doubt, feel free to ask and watch the video repeatedly, note down the contents. Okay, reflection and shear are also the important forms of the transformation only. The major type of transformation, we have translation, rotation and scaling. Along with that, some additional form of transformation, of they are of two types. One is reflection, that's what we have seen in the previous video. So note down the contents, write down the matrices, that is the homogeneous coordinate system representation, 3x3 matrix, since it's a two-dimensional model, right? And this is the homogeneous coordinate system matrix representation for shear. Okay, note down the contents. If you have any doubt, you ask. Thank you for watching.